All right, so we can draw one thing to the screen, but how do we pass data to the GPU and draw more than one thing? Let's get into it. So here's where we left off. The first thing that we're going to want to do is we want to somehow replace this with data that we are going to pass in. And the way that we do that is we basically are going to pass a struct into this, but we have to specify a lot of stuff manually. So what this says is I'm going to give you some data. The data is going to be at position 0. Right now, this is all we're sending. So we might have more data than this, and it's helpful to know what the position is. So we have to keep track of a lot of indices and stuff. It's going to be a vec2, so it's going to be 2 floats. And then we're going to put that data in here. So we're going to pass in data, and that will be our position. So this is the shader side of things. Now, how do we do this on the JavaScript side of things? It's, again, going to be quite a bit of boilerplate, but it's really not so bad. So first of all, let's generate some random numbers. And we want to parameterize this just so that we can see what happens with things like performance as we want to display more data. And this might be something you've never seen before. So a float32 array is exactly what it sounds like. It's an array of float32s, 32 meaning 32-bit or 4 bytes. So whenever you're doing graphic stuff, if you're doing it to see it, then you're pretty much always using 4-byte floats. If you're doing scientific computing or something, then you're using a graphics card that has 64-bit. But you never need that. Your eye can't really distinguish it. And there's plenty of precision with the 4-byte floats. So now let's just generate some random data. So let's see, we want math.random. And one thing that we haven't covered yet is that the coordinate space for OpenGL is always between -1 and 1 in all axes. So x, y, z, always between -1 and 1. So we're going to generate numbers between -1 and 1. All right, so now we have some data. How do we send it over to the graphics card? The first thing that we need is we don't really need this, but it's going to be helpful later. We want a vertex array object, and this will be helpful for referring to it later. So when you have a more complicated program, you want to switch out array objects and render them separately. So now we want to bind the vertex array, and this is a common thing that you'll see with OpenGL is you have to bind and then you do stuff. If you do stuff without binding, you're going to be manipulating data that you don't want to manipulate. Possibly someone else's data. So now we make a buffer. What is a buffer? It's just an array. So we make this reference to a buffer, and then now we're going to fill that buffer. And this is going to be the thing that actually pushes the data from memory to the graphics card. And almost forgot to bind the buffer. And this static draw just says that we're not going to be changing this data very often, so put it into fast memory. So now we want to enable 0. We want to enable this A position. And the reason we prefix it with A is the variables between vertex and fragment shaders, they're all in one big pool. So you just prefix things to kind of keep them straight. And now this is very tedious, but basically what we're doing is we are manually specifying things about our data. So in this case, we're sending over 2 floats, stride and offset. If we had more than one data source, we would need to also worry about those things. So you're actually having to specify kind of like the math of the struct. But again, a little bit annoying, really not so bad, especially for what it gets you. And let's see. Okay, something has happened. Right. So let's try with, this is a bit big. So let's have smaller points and let's have more of them. All right, we're only seeing 1 point. Why is that? It's because here, whenever we draw arrays, we have to say how many points are we going to draw. So now, there we go. We've got 5 points being drawn. And yes, all of this is very tedious, but what does it get you? Why are we going through the trouble of doing this? Well, let's see. How many points can we draw? Maybe 10,000? Oh, right. Let me replace this with num points. Okay. Doesn't seem to be a problem. Maybe 100,000? Also doesn't seem to be a problem. Let's actually get some numbers in here. So before we actually send the data over to the GPU, let's see how long it takes to actually send the data and render the data. And once we're all done, let's see how long it took. Oh, these, there we go. Okay, so half of a millisecond for 100,000 points. Let's see, a million points. All right, 3 milliseconds, a million points. We can make this even smaller. So just how far can we push this? 30 milliseconds for 10 million points. All right. 300 milliseconds, 100 million points. At this point, it's unusable, but it's still, we're getting 4 FPS at 100 million points. And that's including sending the data to the GPU. We won't actually be sending the data to the GPU every time. Most of the time, we buffer the data and then we just leave it there. But even if we need to take the data from memory to the GPU, we can render so much stuff. So that is why this is worth it. And if we look, we can see, okay, yeah, we're using a gigabyte. If we do some quick math, let's see. So 1 million times 8 bytes per point. It's roughly 8. Oh, wait, no, we're doing 100 million. Okay, yeah. So, because, yeah, 1 million would be 8 megabytes. 100 million is 800 megabytes. So, yeah, we're using a lot of RAM, but still, this is just insane.